All right, we're doing our first video here for Mod 22, picking up with question number 4, which is where you would have stopped before starting these videos. Please be sure that you have your hypothesis testing grading guidelines nearby. I'm going to refer to them all the time. I know they're super small over here on the left, but I was trying to get everything to fit on my screen. Let's go ahead and take a look at our first question that I have adapted from a Learn by Doing from OLI. We're going to do the full hypothesis test here, though. Okay, let's see what we have here. According to the Centers for Disease Control and Prevention, 60% of all American adults age 18 to 24 currently drink alcohol. So hopefully you identify that they're talking about a population value here. So this is telling us that our population proportion P is equal to 60% or 0.6. Here's our question. Is the proportion of California college students who currently drink alcohol different from the proportion nationwide? So we're going to see if this baseline amount of 60% applies to California college students. And in particular, that we're looking just, is the proportion different, is going to lead us through setting up our null and our alternate hypotheses. Let's just continue reading to see what's going on in our sample. A survey of 450, so that's our sample size, random California college students, indicates that 66% currently drink alcohol. So since that is about what's going on in our survey, that is our p hat value. So step 1 is to set up our null and alternate hypotheses. That's something we've already gone over. Why don't you pause the video and see if you can write those statements yourself. All right, here is what I have come up with for step 1, writing my null and alternate hypotheses. For the null, the proportion of California college students who drink alcohol is 60%. So P equals 0.6 is our symbolic statement. And then for the alternate, the proportion of California college students who drink alcohol is not 60%. So P does not equal 0.6 for our symbolic statement. All right, so taking a look over here, so we've done step 1, our hypothesis statements. Now we are on to step 2, and right now we're dealing with population proportions. So let's see what we need to do there for step 2. Either state or calculate p hat. Well, in this particular setup, they've just given us the p hat amount. We wrote that down earlier. It is 0.66. The next thing we do is confirm that we have a random sample. And we are told that we have a random sample, so that's good. Let's just note that here. Check. We're good with that. And now the last thing is we need to note that our sample size is large enough to ensure that we have 10 or more both expected successes and failures. So NP for this problem is 450 times, we assume HO is true, so P equals 0.6, which gives us 297, which is certainly bigger than 10, so we're good to go there. And NQ is 450 times 0.4, which is 153, again bigger than 10, So we're good to go there. So remember, it's these two criteria together that are ensuring that we have a normal sampling distribution of sample proportions. Just like a confidence interval, we need that normal sampling distribution to conduct our hypothesis tests. Okay, on to step 3. Over here, this is where we are assessing our evidence, which is all about our p-value. So the first thing that I want everybody to do is draw this sampling distribution of sample proportions. Each number along the horizontal axis represents a different p-hat value. We just confirmed in step 2 that we have a normal SDSB. Right here at the center is 0.60. We know that the mean of all the p-hat values is p, and for right now, we believe HO that p is 0.60. Last thing we need to do on this picture is identify to which side of center our sample statistic lies. Well, our p-hat value is 0.66. This is a number line, so our p-hat value must be to the right of center because 0.66 is bigger than 0.6. Okay, so that's where we are. Last thing we need to do, oh no, 2 more things. So state our p-value as a conditional probability about the sample statistic. Okay, our p-value is the probability that p-hat is either equal to the 0.66 that we have, or something more extreme. Where's more extreme? Well, that is greater in this case, under the condition that p equals 0.6, like HO says it is. Okay, so this is our p-value stated as a probability about our sample proportion p-hat. Now, actually, there's a little trick to this one. We haven't really looked at an alternate hypothesis of not equals before. It turns out that when that's a not equals, the p-value is actually twice this probability. But I don't want us to get bogged down in it. Nothing is really different. The p-value that comes out of StatCrunch is going to be exactly the p-value that we need. We don't need to multiply it by 2, and frankly, on your final exam, I'm not going to give you a not equals like this. So here I've shown you, but let's not worry about it too much. All right, so to get this answer, we're going to go to StatCrunch and we're going to choose the proportion stats function, just like we would have for making a confidence interval. So let me go over here. Oops, let's pretend I didn't have that yet. So you're going to stat, picking proportion stats. We have one sample, and we have the summary of our data, right? There are 450 pieces of data, but we don't have them. We just have the summary of that data. So these are the choices we're picking. Number of successes. Well, they didn't actually tell us the number of successes. They told us that in our sample, we had 66% of that sample doing what we wanted, and our sample size was 450. So to get the number of successes there, we're going to take 0.66 and multiply it by 450. And we get 297. So 297 is 66% of our sample of 450. So that is the number of the sample that are currently drinking alcohol. Number of observations is our sample size of 450. We are performing a hypothesis test, so we're going to leave this choice chosen. Our null hypothesis says that P is equal to 0.6, and then our alternate says not equal, so we can leave that alone. You just click here and choose greater than or less than if that's appropriate, but this one is not equals. And we click compute, and we get the two things that we need. Notice here's that sample proportion of 0.66, which was just 297 divided by 450. What you see up here should match your null and your alternate hypothesis statements on your paper. If it doesn't match, then obviously you picked something wrong. Standard error, this is the standard deviation of that normal SDSP we used to calculate with that formula. Here it is right here in this answer. We don't really concern ourselves with that anymore. StatCrunch would have used that to calculate the p-value, but here's our p-value right here. That's all that we need. I'm going to go back to my paper. So my p-value is 0.0094. So under the condition that the proportion of students drinking alcohol really is 60%, really is 0.6, we would get sample results like we got, or something more extreme, about 0.94% of the time, right? The p-value is 0.0094. It's a probability. We know we can interpret a probability about how a percent of how often something would happen. So that's where I got that. The other thing our grading rubric here says that we need to do is find the value of the test statistic. And the test statistic in this case is the z-score of our p-hat value of 0.66. And we got that in our results screen right here. Z-stat is our z-score. So if I round to 2 decimal places, that is 2.60. So just to put this together in our picture here, let's see, a z-score of about 1 would be there, about 2 would be there, 3 would be there. So my p-hat value is about right in there, 2.6 standard deviations above the mean. And then my p-value is this shaded area actually plus this shaded area over here because of this whole not equals business. But both of those things, this tiny, tiny p-value and this z-score telling us that our p-hat value is very far from center, both of those things are telling us that our sample value results are extremely unlikely when p equals 0.6. So we believed that p was equal to 0.6. Something very unlikely has happened. When that is the case, we reject our null hypothesis. So we're going to forget about that. Instead, we're going to support our null hypothesis. And it is from that information that we're going to draw our final conclusion. Okay, we are working on step 4, our final conclusion. Let me get everything back here where you can see it. Okay, so this is what I have you writing here. An if, then, therefore statement, okay? So our if is really just our word sentence about the null hypothesis being true. We believe the null hypothesis is true all the way through this hypothesis test, right up until our therefore conclusion. So here I might say something like, if the proportion of California college students who drink alcohol is 60%, then. So in our then, we're going to talk about the likelihood of our sample results, and this is based on our test statistic and our p-value. So remember, our very tiny p-value and our z-score telling us our p-hat is far from center, both of those things let us know that our sample results are extremely unlikely. So I might just write, then our sample results are extremely unlikely. Therefore, our therefore statement is always talking about the alternate hypothesis. And when I'm talking about these statements being contextualized, I mean that you have to talk about the data and the populations that you have at hand. You don't want to just say, therefore I support HA. That is not in the context of this particular hypothesis test that we're doing. So we rejected HO, we support HA, which is essentially this sentence we have here for HA. So therefore, our data supports the proportion of California college students who drink alcohol is not 60%. And that is our final conclusion. So in your if, you're just restating the sentence of your null hypothesis. Your then is talking about the likelihood of your sample results. You're deciding on that from your p-value and your z-score. And then your therefore is always talking about the alternate hypothesis. And remember, the alternate hypothesis either gets supported or not supported. Those are your only two options, and we supported it in this case.